The main goal of this lab was to compare ratio of amounts used between the reactants of copper sulfate and potassium hydroxide to observe how these amounts manipulated the precipitate formed. By measuring and analyzing the precipitate, we can then determine if and where a limiting reactant is present. The chemical reaction observed in this lab was 2 potassium hydroxide to 1 copper sulfate, which reacted to form the products of copper hydroxide and potassium sulfate. The reactants tell us the mole ratio, that there were 2 moles of potassium hydroxide that reacted with 1 mole of copper sulfate in the solution. This mole ratio essentially creates a perfect ratio in the reaction and the amount of products in which both reactants are proportionate. When reactants are not used in the perfect ratios, a limiting and excess reactant become present. A limiting reactant is a substance that yields the least amount of product, while an excess reactant is the reactant that contains greater amount than necessary to react completely with the limiting reactant. Concentration, shown in molarity, is valuable in also identifying the limiting and excess reactants. Molarity shows the amount of particles present in a certain amount of space. Also in this lab, the reactants were soluble substances before mixing, but after mixing in the solution form insoluble substances, which cannot dissolve in water at room temperature. These insoluble substances that emerge in the mixture essentially is called the precipitate.
To perform this lab, we used 2 reactants in water. One of the solutions was 0.2 moles concentration of potassium hydroxide and the other was 0.1 mole concentration of copper sulfate. First, we numbered the test tubes 1 through 8. We then filled each test tube with 5 milliliters of copper sulfate. Then we put 1 milliliter of potassium hydroxide in the first tube, 2 milliliters in the second tube, and continued the pattern until eventually filling the last tube with 8 milliliters. After that, we fill the rest of the test tube with water so that each test tube has a solution of 13 milliliters. Then we mix the solution and waited for the precipitate to form. After making observations of the precipitate, we grabbed the ruler and measured the height of the precipitate in millimeters.
After staring and waiting 15 minutes, we first found the valence equation of the reactants and products, and then waited for the reaction to take place. We found that the height of the precipitate rose steadily in the first 5 test tubes. The other 3 test tubes could measure the same height of precipitate and stayed rather constant instead of continuing the trend of test tubes 1 through 5. Another thing we observed was that in test tubes 1 through 5, there were lighter shades of blue compared to a darker shade of blue in test tubes 6 through 8. Our precipitate measurements are shown here.
In all 8 test tubes using molarity for copper sulfate, there was 5 10,000ths moles of the copper sulfate reactant. We again used molarity to find 2 10,000ths moles of potassium hydroxide in test tube 1, and the moles of potassium hydroxide increased by 2 10,000ths for each test tube. Determining the moles for test tubes 1 through 4 helped us determine that for test tubes 1 through 4. The limiting reactant was the potassium hydroxide because when dividing the potassium hydroxide by copper sulfate, it would not equal the original value of the 2-to-1 ratio, but rather a lower value like 0.4 potassium hydroxide to 1 copper sulfate for test tube 1, for example. Meaning there was less of the potassium hydroxide in these first 4 test tubes and more of the copper sulfate. This meant that the limiting reactant for test tube 6 through 8 was the copper sulfate, because when dividing the 2 reactants, you would get a ratio higher than the original 2-to-1, like 2.4 potassium hydroxide to 1 copper sulfate in test tube 6, meaning less copper sulfate and more potassium hydroxide. The precipitate level stayed constant in test tubes 6 through 8 because the limiting reactant changed into copper sulfate from the potassium hydroxide from test tubes 1 through 4, thus limiting the amount of potassium hydroxide precipitate formed in test tubes 6 through 8. This means that an excess reactant of copper sulfate in test tubes 1 through 4 accounted for a lighter shade of blue solution, while an excess reactant of potassium hydroxide accounted for a darker shade of the blue solution. As for test tube 5, it contained the perfect ratio because if you divide the amount of moles of potassium hydroxide to the amount of moles of copper sulfate in test tube 5, it will equal the original ratio of 2 potassium hydroxide to 1 copper sulfate, meaning there would be no limiting or excess reactant.